Hello and welcome to Calc 3. We're doing checkpoint 1.7. They want us to find the area under the curve of the hypocycloid defined by the equations, and there's the given equations over here. So let's see if we can work this out. It might be good to get an idea of what this thing might look like, and I think for this I'll start off with a short table. I don't want to do the whole thing, but we're going to go from 0 to pi, so it might be worth examining what happens at 0 and at pi, and maybe just one more point in the middle, pi over 2. Alright, let's put 0 in there. For the x value, the cosine of 0 is 1, and so it'd be 3 plus 1 is 4. So it looks like the x value is going to be 4, and then the y value 0 minus 0, so it's 4, 0. When we put pi over 2, cosine of pi over 2 is 0, so it looks like the first component is 0, and the second component it'll be 1, so sine of 1 is 1, and pi over 2, so that's 3 pi over 2. I think that goes down, so that's negative 1, so this gives a 4 also. And then finally at pi, the cosine is going to be negative 1, cosine of pi, so it'll be 3 minus, and then 3 pi is also going to be negative 1, so that's going to be negative 4. And sine of pi is 0, so that whole thing is going to be 0. So we have a few points. We can see that it starts here when t is equal to 0. We're at 4, 0. And when t is equal to pi over 2, t equals pi over 2, we are looking at 0, 4, and then over here when t is equal to pi, we're looking at the point negative 4, 0. And it's a hypocycloid, so I think the graph is going to go like this. We can verify that. This is a cusp. It's not a bell curve. It's a cusp. Okay, so we're looking for the area under this curve. Now, one thing to note is the movement, or the direction that this is going from right to left. So that's going to be significant for us. When we do integrals, we tend to look at integrals from left to right, but here we're moving right to left. So when we integrate this, we're going to be pretty concerned about the direction that this is going to go. All right, so let's just keep that in mind. If we were able to express this function as f of x, as y is equal to f of x, then we can say that the area under the curve is going to be the integral from a to b, again, a being this point over here to b being this point over here, of f of x dx. All right, now since we have parametric equations, what we're going to need to do is we're going to shift this to the parametric equation form. And so this f of x is actually y of t. And so we have a y of t there. And then dx is actually the differential, and that would be x prime of t dt. Okay, and now we're going to integrate. Now the point A happens when t is equal to pi. So when t is equal to pi, that's the lower limit of the t value. And the upper limit is when t is equal to 0. So notice that this is going from pi to 0 instead of going from 0 to pi. Okay? All right, so now let's do the work to get these values. I want y of t is there. Let's take a little bit of time to find out x of t, or x prime of t. And x is going to be, the derivative of cosine is negative sine, so it's negative 3 sine t, and another negative because the derivative of cosine is negative sine, and then that's going to be sine 3t times 3, so let's put that 3 out there. So this is your derivative, and we just need to string that up in a long set of equations. So the area, let's move that over a little bit. Area will be equal to y. What was y? Or the integral from pi to 0. Y is 3 sine t minus sine 3t times the derivative that we just found, negative sine t minus 3 sine 3t, and dt. Okay, well, this would be kind of difficult to do by hand. It's not impossible. You would FOIL it out and you get a sine squared t and then a sine squared 3t, which will require a half angle formula. You'll have a middle term when you FOIL it out, a combination of sine t and sine 3t, which is yet another formula. So again, it's not impossible to do by hand. But if you put it into a computer program, like an integrating program, like Wolfram Alpha or Symbolab, this will end up getting you 3 pi. So let's just say ... I did it using Wolfram Alpha, and this is going to end up being 3 pi. All right, so that's your area. I hope that helps.